Hello friends and my dear students, I welcome you all to my channel. This is part 12 video on the chapter of squares and square roots, where I will solve the sample test paper number 2 on the chapter of squares and square roots. This sample test paper has 12 multiple choice questions, and ideally you should be able to solve it in 45 minutes or 1 hour at maximum. If you have not watched the previous video where I solved sample test paper number 1 on the chapter of squares and square roots, I highly suggest and request that you watch that video also. And if you have not watched all the theoretical videos, that is part 1 to part 10 on the chapter of squares and square roots, I will strongly suggest that you watch them also for to maintain the continuity of your preparation on this chapter. So this video is part of the playlist CBSE Maths for Class 8 following the textbook of author R.S. Aggarwal. If you are new to my channel or not yet subscribed, if you are watching this video for the first time, and if my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So let's start solving the sample test paper number 2. Okay, so I have the sample test paper number 2 on the left hand side. I hope it's visible. You can see the question paper properly. And on the right hand side, I will solve the problems. It is always recommended that you first solve the problems yourself first. And if you are only stuck at any problem, and if you cannot solve it after multiple attempts, then only you see this solution video as a reference. And while I will be solving the problem, I will pause for a few seconds after solving a problem so that you can take a screenshot of the solution. So let's start solving the problem. The first problem says that if 4k, 63 and 65 forms a Pythagorean triplet, then the value of k is. Okay, so we know that now a Pythagorean triplet is now definitely uh, the definition of a Pythagorean triplet is that if 4k, 63, 65 has to be a Pythagorean triplet, we must have 65 square must be equal to 4k square plus 63 square. That is, the sum of the squares of the first two numbers should be equal to the square of the third number in the triplet. Okay. Now from here, if you try to solve the problem, you can solve it, but I think there is a now. Okay, let's try to solve from here. If you try to solve it, what I will do is that I will not compute 65 square and 63 square. Rather, what I will do is I will rewrite the equation as 4k whole square is equal to 65 square minus 63 square. Now I know there is a algebraic identity or formula, you can say, that a square minus b square is for numbers a and b, for constant numbers a and b, we know that a square minus b square is equal to a minus b multiplied by a plus b. Using this formula, we get this is equal to 65 minus 63 multiplied by 65 plus 63. Okay, this is equal to 65 minus 63 is 2 multiplied by 65 plus 63 is 128. Now this implies the left hand side 4k whole square means 4 square multiplied by k square is equal to 2 multiplied by 128. Now this implies this implies k square is equal to 2 multiplied by 128 divided by 4 square. Now you have to simplify this rational number, this fraction, by doing cancellation. Now uh, it is better if you can express this in a form of square, then directly you can get the value of k. Now 2 into 128 is 256. 256 divided by 4 square. Now 256, if I know it is a whole square, perfect square, that is 16 square. 16 square is 256. So we have 16 square by 4 square. This will be 16 by 4 whole square. This will be 4 square. This implies that k has to be equal to 4. K square is equal to 4 square. This means that k has to be 4. Okay, so the correct choice is C. This was one way of solving the problem, and the other way that I can think of is that you also know that for m greater than m, for m greater than m, 2m twice m comma m square minus m minus 1 and m square plus 1 is a Pythagorean triplet. If you take for any m is a natural number but greater than 1. If you substitute any natural number m, any value of m which is a natural number greater than 1, so this 2m comma m square minus 1 comma m square plus 1 will be a Pythagorean triplet. Now if you somehow if you compare this with the triplet given 4k comma 63 63 and 65, this I can write it as twice of 2k and 63 and 65. 63 and 65. Now if so, from here if you compare, so I'm trying to see whether the given Pythagorean triplet can be represented in the form of 2 twice m comma m square minus 1 comma m square plus 1 for some natural value of m. I'm trying to find that m, so that if I can find that m, then I will be able to find k. Now so 4k comma 63 comma 65 I have rewritten as 4k as 2 into 2k. Now if considering so from here if this has to be if this has to be the given triplet is a Pythagorean triplet, if it's a Pythagorean triplet, for that Pythagorean triplet, if we can indeed find a natural number m greater than 1, so that the given Pythagorean triplet can be expressed as 2 twice m comma m square minus 1 comma m square plus 1, then we can say that m will be twice k. This implies 63. This implies m will be 2k, and this implies, since the second triplet is m square minus 1, that has to be equal to 63. So 63 m square minus 1 will be equal to 63. This implies m is 2k, that is 2k square minus 1 is equal to 63. This implies 2k square will be equal to 63 plus 1, which is 64. This implies 4k square equals to 64. This implies k square is equal to 64 by 4, which is 16. This implies k equals to 4. So this was another method of solving the problem, but we could apply this concept. This was another method. We could apply this concept because we can see that the first triplet, in the given Pythagorean triplet, the first number is 4k, which can be expressed as twice m for some m natural number greater than 1. Okay, so you can solve this problem in these two ways. Both the method will take, I guess, equal number of same time. It does not make much of a difference. Okay, let's do problem number 2. Okay, problem number 2 says let x is equal to square root of 6889. Then the value of some expression is given. We have to find its value. Okay, in the given expression we can see x square. We can see the term x square. Okay. If x is equal to square root of 6669, okay, now it is given that x is equal to square root of 6889. Now you have to be very careful in understanding the problem whether indeed we need to find the value of square root of 6889. That is, if we need to find the value of x. But before that, let's see what is the given expression. The given expression is x square divided by 10 to the power 4 plus x square divided by 10 square. Now this is equal to x square divided by 10 to the power 4 plus x square divided by 10 square. This is equal to, we can say, x square by, so x square 10 to the power 4, we can write it as 10 square whole to the power square, and we have this x square by 10 square can be written as x by 10 whole square. This is equal to, we can write as x by 10 square whole square plus square root of x by 10 whole square. Now this is equal to square root of, if you have inside a square root some square, then definitely this is very clear that square root of x square is obviously equal to x. So this is equal to x by 10 square plus, and this we have x by 10, which is equal to x by 100 plus x by 10. So we have to find the value of x. Okay, so x is said to be 6889. So x is square root of 6889. Now to find the square root of a number, of a natural number, you can proceed with two methods, either by the prime factorization method or the long division method. Now I find for large numbers, I find the prime factorization to be a little inconvenient. I find always the long division method to be uh, uh, more easy for me to find for the square root for large numbers. So, but whichever method, prime factorization or long division method is easy for you to find the square root of a given large number, you can use that. So we have to find the value of x, which is square root of 68889. So I will use the long division method to find the square root of 6889. So we mark the periods 89 and 68, and then we start with the leftmost period 68. The divisor will be of course 8, and somehow I can feel that. Now always remember some fundamental concepts, that if a so 6889, possibly it will be a perfect square. Now, if it is a perfect square, if we assume that 6889 is a perfect square, then it has 4 digit, and 4 digit which is even. So the number of digits of its square root will have 4 by 2, that is 2 digits. 2 digits, and we know the last digit of the number 6889 is 9. So its square root, the last digit, its square root will end either with the digit 3 or 7, because we know that 3 square is 9, and also 7 square is 49, which ends with 9. So the square root of 6889 can either end with 3 or 7. So obviously we can see that the square root will either be 83 or 87. Now it's better we do it. So 64, we have 4, we bring down the next period 489. The next partial divisor will be 8 multiplied by 2. That is, the current question is 8 multiplied by 2 is 16, and then I guess it will be 3. It will be 3. So it is 83. So 3 will be appended to the question, and 163 multiplied by 3 is 9, 489. So the square root of, so x equals to square root of 6889 is equal to 83. So this implies x by 10. So this was the value of the expression given, x by 10, x by 100 plus x by 10 will be equal to, x is 83, 83 by 100 plus 83 by 10. This is equal to 0.83 plus 8.3, which is equal to 9.13. So 9.13 is the value of the given expression. So the correct choice is D. Correct choice is D. Okay. Okay, let's do problem number 3. Oh, what is wrong? Why can't you see problem number 3? Wait a second. I think something is wrong. Give me a moment, please. This is not okay. 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 Now let's do problem number 3. Okay. So problem number 3. Problem number 3. It is given that a ratio. It is given that x is to y is proportional to proportional to 1:3. That is, it is given that basically x by y is equal to 1 by 3, and Also it is given that square root of y square minus x square divided by y square plus x square is equal to 2 by square root of k square plus 1. Then the value of k. Okay, from this information we have to find the value of k. Now first of all, from the given ratio between x and y, we will uh, mm, we will find x in terms of y, or rather y in terms of x. So from this ratio we can say that y is equal to 3x. Y is equal to 3x. Now this implies that square root of y square minus x square divided by y square plus x square uh, will be equal to square root of, if I substitute y as 3x, we get 3x whole square minus x square divided by 3x whole square plus x square. So this is root over square root of y square minus x square divided by y square plus x square is the LHS. Is the LHS of the of this given equation. This is equal to square root of 9x square minus x square divided by 9x square plus x square. This is equal to 8x square divided by 10x square. X square cancels out. This is equal to square root of 8 by 10. If you cancel, if you simplify 8 by 10, the fraction 8 by 10, it is 4 by 5. So this is equal to square root of 4 by 5. Okay. This implies the left hand side of the given equation has come out to be square root of 4 by 5 as per based on the using the information that x by y equals to 1 by 3. Now we can say that square root of 4 by y is equal to the right hand side of the given equation, the second equation, that is 2 by square root of k square plus 1. Squaring, if we squaring both sides, whenever you have this kind of equations where you have square root on the left hand, on either side or on any side, you can always square to get rid of the square roots. Squaring both sides, we get square root of 4 by 5, this whole square is equal to 2 by square root of k square plus 1, this whole square. We just squared both sides. Now this implies, we know that square root of x, if we square it again, is nothing but x. Square root of x, if you square, the square of the square root of x is always x. So this implies 4 by 5 is equal to, now 2 by square root of k square plus 1 is equal to 2 square divided by k square plus 1 whole square. The concept is x by y whole square, where x and y are some rational numbers and y is obviously a non-zero rational numbers. X by y whole square is equal to x square by y square. So this is equal to, now 2 to the power square is 4, and again square root of k square plus 1 is k square plus 1. So this implies you can cancel 4 from both the sides. On the left hand side, the equality equation, the left hand side is 4 by 5 and the right hand side is 4 by k square plus 1. So you can cancel 4 and you can cancel 4 and we get 1 by 5 is equal to 1 by k square plus 1. From this, you can do cross product from this equation. Now we have our equation where the unknown is k, but it is k square. K is the unknown, we have to find the value of k. So doing cross product, we get k square plus 1 equals to 5. This implies k square is equal to 5 minus 1, which is 4. This implies k is equal to square root of 4, which is 2. So the value of k is 2. So the correct choice is A. A is the correct choice. Okay, let's do problem number 4. I just decreased the font of the question paper. Let me see if you can see it. Okay. Question number 4. It is given that let P equals to 79 into 80 into 100 plus 25. Then the value of square root of P is. Okay. Now, as you can see that the value of P is definitely a constant. P is given to be as 79 multiplied by 80 multiplied by 100 plus 25. Now, P is given, obviously the value of P is a constant. Now, why is it given in this way, that 79 multiplied by 80 multiplied by 100 plus 25? Because it is based on some fundamental concept of finding the square of a number which ends in the digit 5, and it is asking to find the value of square root of P. Now, the concept is, we know that for a number, for any number ending with digit 5, we have for any number, let's say the number is of the form A5, where the 5 is the ending digit, and A is a natural number which can have multiple digits, 1 or 2 or 3 or 4. So where A is a number having 1 or more digits. So A5 will be definitely a number ending with the digit 5. And since I'm just discussing the concept. Any number, if you represent any number that ends with the digit 5, we can always express that as A5, where the 5 is the rightmost digit, that is the digit at the units place, and A is the number every other digits to the left of the digit 5, that is A is a number having 1 or more digits. Then the formula or the result is that if you take the square of this number, that is a number ending with the digit 5, if you take the square, this is nothing but what is A5? I can write A5 as A multiplied by 10 plus 5, and this is whole square. Why? I can write a5 as multiplied by a multiplied by 10 plus 5, because we know if you write a5 in the expanded form, it will obviously be a multiplied by 10 plus 5. Uh, consider let's say 15. 15 is 10 plus 5. Consider 125. 125 is 12 into 10 plus 5. Consider 395 is equal to 39 multiplied by 10 plus 5, and so on. So I can always write the number a5 as a into 10 plus 5, where a is a number having one or more digits. Now this is 10a plus 5 square. Now this is a plus b whole square form, and from the formula we know that a plus b whole square is equal to a square plus twice ab plus b square. We know this formula, a plus b whole square equals to a square plus twice ab plus b square. Applying this formula in 10a plus 5 whole square, we get 10a square plus 2 multiplied by 10a multiplied by 5 plus 5 square. This is equal to 100 a square plus 2 into 10a into 5 is 100 a, and we have 5 square is 25. Now this is equal to, if I take 100a common from the first two terms, I get 100a plus 1 plus 25. Now you can see that any number ending with the digit 5, any number of the form a5, where the number a can have one or more digits, its square will be 100 into a plus 1 plus 25. Okay. Now if you see the given problem, that p is given to be 79, p is given to be 100 multiplied by 79 and 80, we can say 79 plus 1, and we have 25. From here, and the concept that I just discussed, that a5 whole square, the square of a number ending with the digit 5 in the form a5 is 100a into a plus 1 plus 25. Now if the given number in the given problem p is given to be 100 into 79 plus 1 plus 25, so this clearly implies that for the number p, the a of p will be equal to 79. This implies now p is given to be, this implies square root of, we have to find square root of p. So if square root of p is equal to a 5, because we can clearly see that, okay, sorry, so we can say that this number p, which is given to be 100, now we have expressed p as 100 into 79 plus 1 plus 25. This has to be clearly the square of 795 square. 795 square, because we know that any number ending with the digit 5 if we express that as a5, where a is a one digit or a number having one or more digits, then its square, if the square of a5 is 100a into a plus 1 plus 25, so definitely 100 into 79 plus 1 plus 25 will be the square of 795. So p is definitely 795 square. So this implies square root of p is definitely 795. 795. Okay. So the answer is choice B. Okay. Let's do problem number 5. Uh, the value of square root of, okay, so we have to find the value of the given decimal number, square root of the given decimal number. Okay. Now, sometimes it is convenient. Now, if you are familiar with finding the square root of a decimal number using the using the long division method, if that is very clear, you can directly apply that method. But if you are not that convenient or clear enough to find the square root of a decimal number using long division method, but you are clear about finding the square root of a natural number using the long division method, then you can always convert the given decimal number into a fraction. That is, so the given number is 0. There are 4 zeros, and then we have 7396. So this is, if you convert it as a fraction, this will be after the decimal point. What is the decimal places of this number? It is 8. So this number will be 7396 divided by 10 to the power 8. And so this implies that square root of the given number, that is 0.0007396, will be equal to square root of 7396 divided by 10 to the power 8. This is equal to, we know, square root of 7396 divided by square root of 10 to the power 8, because we know from the two properties of square roots that square root of x by y, where definitely y is not equals to 0, x and y are rational numbers and y is not equals to 0, square root of x by y is equal to square root of x divided by square root of y. So this we get square root of 7396 divided by square root of 10 to the power 8 is 10 to the power 4. You must be very aware and clear about the fact that square root of any number in the exponential form, let's say x, which is a non-zero rational number, x to the power twice m, that is power is an even number. Power is an even number, whether it's a positive even number or a negative even number. Its square root will always be x to the power, the power gets divided, that is m. Or even if you have x to the power minus 2m, whatever the power is, positive or negative, you just, if it's inside a square root, the power gets divided by 2. So this is equal to x to the power minus m. This you must be very clear of. So that is the reason square root of 10 to the power 8 is equal to 10 to the power 8. 10 to the power, the power will be 8 divided by 2, that is 10 to the power 4. Now we have to find the square root of 7396. Now you can find the square root of 7396 using prime factorization method or using long division method. I always prefer a long division method. For me it is easier because I do not find that convenient and comfortable to do the prime factorization. So I will find the square root of 7396 using the long division method. I mark the periods, and then I know the leftmost period is 73. I know the divisor, so the initial divisor has to be uh, 8, 8, 8, 64, and the remainder is 9. I bring down the next period, that is 996. The next divisor will be whatever the current question is multiplied by 2. So 8 into 2 is 16. And now I have to find the digit x after 616 such that the 3-digit number 16x multiplied by x is less than equal to 996, and the x has to be the maximum. The maximum value of x is a digit, the maximum value of x which is a digit such that the 3-digit number 16x multiplied by x is less than equal to 996, and this implies what can x be? I think x will be equal to 6. So x will be 6. So we write 6 over here. We add 6 to the question, and 166 multiplied by 6 is 996. Remainder is 0, and there are no more periods left. So the square root of the question is the square root of the given number, that is square root of 7396 is equal to 86. And so we can say that the given square root will be the square root of 7396 is 86 divided by, we have 10 to the power 4, which will be equal to 0.0086. 0.0086 is the answer. So the correct choice is B. Is the correct choice. Okay. Let's do problem number 6. Okay, one equation is given. On the left hand side, there is a square root, and we see term a inside the square root. And the right hand side is also some products where the last product is just square root of b. Then the value of a by b. We have to find the value of a by b. Okay, so the what is given 0.03 multiplied by 0.3 multiplied by a is equal to 0.003 multiplied by 0.3 multiplied by point b. Now, as you can see, there is a 3, the decimal number 3, with a variable number of decimal places on both the sides. So, and it is better if we convert all the decimal numbers as a fraction, and see. So as a fraction now. Okay, so we can see inside on the left hand side, inside the square root, we have 0.03, which we can write it as 3, which is 3 divided by 10 square or 100, let's say, and 0.3 is 3 by 10, and we have multiplied by a equals to 0. On the right hand side, 0.003 means 3 by 1000 multiplied by 3 by 10 and multiplied by square root of b. Now this implies the left hand side, after further simplification, we can say it is 9. It is 9a by 1000, and the right hand side is 9 by 10 to the power, we have 1000, the denominator 1000 and 10, so 10 to the power 4, and we have square root of b. Now if we take the square of both sides of this equation, if we square both sides, squaring both sides, we get 9a divided by 1000, because the left hand side is nothing but, we know that any the square of the square root of a number x is always equal to the number x. So we are squaring the square root of x. This is always equal to x. Obviously, x has to be a non-zero number. That is a not non-zero number. X has to be a positive number, positive rational number. Okay. So that is the reason when we square both the sides, the left hand side becomes 9a by let me write it more step by step, so which will be clear. So I am taking squaring of both sides. So the square of the left hand side is this, and when we square the right hand side, we are taking the square. Okay, I just squared both the sides of the equality. I squared LHS and RHS, and equality will remain same. We can always do that, because if we have A equals to B, this implies we can always have A square will be equal to B square. Now the left hand side will be 9a by 100,000, and the right hand side will be 9 square will be 9 square multiplied by b divided by 10 to the power 8. Why? Because if you have something like x, if you have something like we know that x multiplied by y, where x and y are some rational numbers, x multiplied by y whole to the power m is equal to x to the power m multiplied by y to the power m. So the right hand side was, you can say, the product of 9 by 10 to the power 4 and root b. So when I squared, take the whole square, it was the square of 9 by 10, 10 to the power 4, and the square of root b. So if you cannot understand this, let me break it down in a more. So this is nothing but you can say 9 by 10 to the power 4 each square multiplied by root b each square. So this implies 9a by 1000 is equal to now 9 by 10 to the power 4 its whole square can be written as 9 square divided by 10 to the power 4 whole square, and root b whole square is b. So this implies we can say 9a, let's say 1000 is 10 to the power 3 is equal to 9 square into b divided by 10 to the power 4, and its square is 10 to the power 8. Okay, now so this implies that 9 by 10 to the power 3 into a is equal to 9 square divided by 10 to the power 8 multiplied by b. From here we can get a by b. From here we can get that a by b is equal to 9 square divided by 10 to the power 8 divided by the coefficient of a, that is 9 by 10 to the power 3. The concept applied is that if you have xa equal to yb, where xa and yb, none of them are 0, they are all non-zero or rational numbers, x, a and y and b. X, y and a and b are non-zero rational numbers. You can always say from here that a by b, that is from the right hand side you bring b down a, and you bring the coefficient of x down to the right hand side, that is y by x. You can say this a by b is equal to y by x. So similarly in this problem we can write that we can say a by b is equal to 9 square by 10 to the power 8 was the coefficient of b on the right hand side, that divided by a 9 by 10 to the power cube, which was the coefficient of a on the left hand side. So we now see that a by b, we have to simplify the right hand side. Now 9 square 10 divided by 10 to the power 8 divided by 9 by 10 to the power 3 means multiplied by the reciprocal of 9 multiplied by the reciprocal of 9 by 10 to the power 3. We know that x divided by y, where x and y are non-zero rational numbers, is equal to x multiplied by the reciprocal of y or multiplicative inverse of y. So this is equal to 9 square divided by 10 to the power 8 multiplied by now the reciprocal of 9 by 10 to the power 3 is 10 to the power 3 divided by 9. Now you have to do cancellation. 9 and this is equal to 9. We have 10 to the power 3 in the numerator and 10 to the power 8 in the denominator. We can say this is at 10 to the power 3 divided by 10 to the power 8. This is equal to 9 multiplied by 10 to the power 3 divided by 10 to the power 8 is nothing but 10 to the power minus 5. 10 to the power minus 5. So this will be equal to, if we convert this as a decimal number, this will be equal to 0.00004 zeros and 9. So this is the value of a by b, and the correct choice is A. Correct choice is A. Okay, let's do problem number 7. Problem number 7 says that it is given that 69 multiplied by k plus 3 square is equal to 66 square. Then k is a multiple of, then k is a multiple of. We have to find that, we have to select the choice whose multiple is a k, whose multiple is k. Okay, now what can we do? Now since this is basically a linear equation in k, you can find the right hand side 66 square, and then you can minus subtract 9 from that, and then you can divide 69, but that will be a long process. You have to be a little more wise in solving the problem quickly. Now first of all, you have to see that there are certain properties of squares. If you can somehow relate this given problem to any of those properties. Now 66 square, 66 square and 3 square is 9, 66 square. No. We have the formulas, there are lots of properties of squares, like the difference of n plus 1 square, n plus 1 square minus n square is 2n, and then the sum of the first n odd positive natural numbers is n square. All those properties you have to keep in mind and see whether you can use any of those to solve the problem. But what I can see is that I cannot think of any such properties, but what I can think is that I can, from here I can say that 69 multiplied by k, I can bring the 3 square on the right hand side. That is, I have 66 square minus 3 square. I know the formula a square minus b square. In squaring in the chapter of squares and square roots, this formula is often widely used. A square minus b square is a plus b multiplied by a minus b. That is basically you are creating factors out of the number a square minus b. You are creating factors for the expression a square minus b square. So this 66 square minus 3 square will be 66 minus 3 multiplied by 66 plus 3. So this is equal to 63 multiplied by 69. So we get 69 multiplied by k is equal to 63 multiplied by 69. Okay, I can obviously cancel 69 from both sides and I get directly k is equal to 63. Now we have to find the we have to see the among the given choices which one is a factor of k. That is, the question is, then k is a multiple of which of the given choices. So we clearly see that 63 is equal to, we see that 63 is equal to, we can write it as 7 into 9, 7 into 9. Since in the choices there is a choice D, which is all of this, so you have to be very careful to see whether all the three choices A, B, and C applies or not, because the choice D is all of this. Now we see that 63 can be written as 7 into 9. So definitely 7 is a, so 63 is a multiple of both 7 and 9. And also we see 63 as 21 multiplied by 3. So 63 is also a multiple of 21. 21, 7, 9. So the correct choice will be D, as all the choices, other choices A, B, and C, that is 7, 9, and 21, they are factors of k, or k is a multiple of 7 as well as 9 as well as 21. So the correct choice is D, all of this. Okay, let's do problem number 8. Find the other two numbers of a Pythagorean triplet whose one number is 12. Now we know that for a Pythagorean triplet, if x, y, z is if x, y, z is a Pythagorean triplet, is a Pythagorean triplet. Now find the other two numbers of a Pythagorean triplet whose number is 12. Now whenever you see, let's forget this one. Whenever you have this kind of problem, that find the other two numbers of a Pythagorean triplet whose one number is 12, you always try to see whether you can have the Pythagorean triplet in the form twice m, comma, m square minus 1 and m square plus 1. That is, where m is a natural number, greater than 1. M has to be greater than 1. So the one of the Pythagorean triplet is given to be 12. Now also is given to be 12. Okay, so you always try to see that if always try to match the given triplet, the given number of the triplet as twice m. So if you let twice m equals to 12, we are considering that the Pythagorean triplet will be of the form twice m, comma, m square minus 1, comma, m square plus 1, and we are assuming that the given one number of the Pythagorean triplet, which is 12, let it be twice m. So we get twice m equals to 12. This implies m will be equal to 12 by 2, that is 6. Now this implies the other numbers will be m square minus 1, that is 6 square, minus 1, that is 36, minus 1, which is 35. And also the third number will be m square plus 1, that is equal to 6 square plus 1. This will be equal to 36 plus 1, which is 37. Now you can see whether if you have the choice 35 and 37, obviously we have. So we can clearly say that The correct choice is A. But remember one thing, that for a given Pythagorean triplet, uh, not all Pythagorean triplets can be expressed as twice m comma m square minus 1 comma m square plus 1. Not all, there are numerous, there are many Pythagorean triplets, and it is not the fact that every such Pythagorean triplet can be expressed as twice m comma m square minus 1 comma m square plus 1 for some natural number m greater than 1. For example, 3 4 comma 5 is a Pythagorean triplet, as you can see 5 square is equal to 3 square plus 4 square, that is 9 plus 16 equal to 25. But you cannot express this Pythagorean triplet 3 4 5 3 comma 4 comma 5 as 2 twice m comma m square minus 1 comma m square plus 1. You will not find any m such that twice m will be 3, because twice m for this Pythagorean triplet twice m comma m square minus 1 comma m square plus 1 will always have the first Pythagorean number as an even number. But you can see the Pythagorean triplet 3 comma 4 comma 5 3 is an odd number. So this Pythagorean triplet, which is expressed as twice m comma m square minus 1 comma m square plus 1, this does not cover all the possible Pythagorean triplets. But if you can at least check whether you can whatever the Pythagorean triplet is, whether one number is given or any other information of the Pythagorean triplet is given. Based on that, you can always try first to see if you can express that Pythagorean triplet in the form twice m comma m square minus 1 comma m square plus 1, and from there if you can find m. If you can, then you are done. Okay, let's do problem number 9. Problem number 9. Problem number 9 is given. Okay, so what is given? 1 plus 3 plus 5 plus 7 plus dot 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 plus k square plus 1 is equal to 81. Okay, then k is. Now on the left hand side we can see that summation of the odd positive numbers is going on. So all these numbers, all these are odd consecutive odd positive numbers, consecutive odd positive numbers. So the odd consecutive positive number starts from 1, and they are 1 3 5 7 and so on. And we can see on the left hand side, definitely these are, the left hand side are summation of some consecutive odd positive numbers, where the last odd number is k square plus 1, and on the right hand side it is given as 81. We know that 81 is equal to 9 square, and we know the formula that for the sum of first n odd natural numbers is n square. We know that sum of first n odd, sum of the first n consecutive odd integer, odd positive integers is n square. We know this property, that the sum of the first n consecutive odd positive integers is n square. So definitely this will imply the LHS, if we consider the given equation, that is 1 plus 3 plus 5 plus 7 up to the last term is k square plus 1 equals to 81. If we consider this equation, from this equation we can say that the LHS is equal to the sum of first 9 odd sum of the first 9 odd positive integers. Sum of the first so this will be the sum of the first 9 odd positive integers. The left hand side will be the sum of first 9 odd positive integers. From where did we get 9? Because the right hand side is given as 81 and we know 81 is 9 square, and from the properties of square numbers, we know that the sum of the first n consecutive odd positive integers is n square. So from this, applying these two information, or using these two information, we can say that the left hand side is the sum of first 9 odd positive integers, and this is what are the first 9 positive odd integers. So this will the left hand side should be 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15. 1, 2, 3, 4, 5, 6, 7, 8. One more, 17. The left hand side has to be 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17. This implies that the last number in the given equation, k square plus 1, has to be equal to 17. So this implies k square is equal to 17 minus 1 equals to 16. This is equal to 4 square. This implies k is equal to 4. K is equal to 4. So the correct choice is D. D is the correct choice. Okay. Let's do problem number 10. If there are n non-perfect square numbers between 25 and m, then value of square root of m is, if there are 10 non-perfect square numbers between 25 and m. Okay, so you can by reading this statement, you should be right away able to correlate some properties of square numbers, which is that there are 2n number of non-perfect square, that is numbers which are not perfect squares, non-perfect square numbers between n square and n plus 1 whole square. So n and n plus 1 are two consecutive integers, so definitely n square and n plus 1 whole square will be two consecutive squares, consecutive perfect squares. So between n square, that is all the numbers that are lying between n square and n plus 1 square, that is excluding n square and n plus 1 square, that is all numbers greater than n square and less than n plus 1 square. All those numbers, if you count those numbers, there are 2n number of such numbers lying between n square and n plus 1 square. Now so in the problem it is saying that there are 10 non-perfect square numbers between 25 and m. If you correlate that with the concept that I have just stated, we can say that twice n is equal to 10, and also n square is equal to 25, and m is equal to n plus 1 square. We can say this, we can have this. We know that there are between n square and n plus 1 whole square, there are 2n number of non-perfect square numbers, and the problem statement is saying that there are 10 non-perfect square numbers between 25 and m. So we can correlate and say that the 2n must be equal to 10 2n. If we want to find the n, if we find If we consider that, mm, okay, so the the problem statement is saying that there are 10 non-perfect square numbers between 25 and m. Okay, so uh, let's for the time being forget this. Uh, it is saying that we know that between uh, we have we can we have uh, between uh, 5 square and between 5 square or between 5 square and 6 square, there are 2 into 5, that is equal to 10 non-perfect square numbers. That is numbers that are not that is not a perfect square. There are 2 into 5, that is 10 non-perfect square numbers, 5 square and 6 square. So, and the problem is saying that, so we have applied the if we apply the concept that there are 2n number of non-perfect square numbers between n square and n plus 1 square. If we put n as 5 in this concept, we get there are between 5 square and 6 square. 6 is 5 plus 1. 5 square and 6 square, there are 2 into 5, that is 10 non-perfect square numbers. So now, using this information and whatever the problem is given, we can clearly say that m has to be equal to 6 square. So this implies the square root of m has to be equal to 6. So the answer is choice D. Okay, let's do problem number 11. Problem number 11 it is okay, so p is given some square root and q is given some square root inside we are having some exponential terms, and then we have to find the square root of pq. So p is given as square root of x cube multiplied by y, and q is given as square root of y cube and x. Now you must be very familiar with this kind of concepts that square root of any exponential term, that is x to the power m, where m is a non-zero integer, that is a positive integer or a negative integer, and x is a non-zero rational numbers. This is always equal to x raised to the power, whatever the power was inside the square root, that power divided by 2. Okay, so now we see p is given, q is given. We have to find the square root of pq. So let's see what is pq. This implies pq will be equal to pq will be equal to square root of x cube y multiplied by square root of y cube x. This is equal to, again the concept we will apply is that square root of x multiplied by square root of y, obviously x and y are non-zero numbers, is equal to square root of x multiplied by y. So we have this is equal to square root of x cube y multiplied by y cube x. This is equal to, if I merge all the powers of x and the powers of y, we get x to the power 4 multiplied by y to the power 4. This is equal to, I know this will be equal to x, this will be equal to x to the power 4 by 2 multiplied by y to the power 4 by 2, which is equal to x square and y square. Now instead of this, instead of writing square root of x to the power 4 into y to the power 4 as x to the power 4 by 2 and y to the power 4 by 2, you can also express this as uh, x to the power 4 and y to the power 4. You can always write it as x square y square and this whole square, and then you can say that its square root will be x square into y square. So we see that PQ is equal to x square y square. So this implies square root of PQ is equal to square root of x square y square, which is equal to x y, which is equal to xy. So we have to now see the correct choice. Now A is xy to the power, A is the reciprocal of xy, which is incorrect. B is, so A is, what is A? A is xy, given xy to the power minus 1 means reciprocal of, this is reciprocal of x 1 by xy. So this is an incorrect choice because the answer is xy. What is B? The choice B, y to the power minus 1 multiplied by x to the power minus 1 and this whole raised to the power minus 1. So this is nothing but y raised to the power minus 1 whole raised to the power minus 1 multiplied by x raised to the power minus 1 whole raised to the power minus 1. This is equal to y into x. This is a correct choice. And obviously C and D are wait, D is also given to be xy. D is also given to be xy. Oh. The answer is xy, but we can see there are two choices which are matching. So I might have done some mistake in writing the choices. So B is, we can see, is correct, xy. The answer is xy, and B is yx, which is equal to xy. So this is correct, and C is x square y square, which is definitely not correct. But and D is also given as xy. So this is also correct. So there is a mistake in giving the choices. Anyway, the answer is xy. Okay, let's do problem number 12. A is equal to square root of 67.36, B is given as square root of 57.12, then the square root of A plus B into A minus B is, okay, so A is equal to, is given as 67.36 and B is given to be square root of 57.12. Now we have to find the square root of the square root of A plus B multiplied by A minus B. Now A plus B multiplied by A minus B, you know its formula is A square minus B square. Now we know A is given, this from this we can say that A is given to be the square root of 67.36. This, from here we can say that A square will be equal to 67.36, and from this we can say that B square will be equal to 57.12. So now square root of A square minus B square becomes, A square is 67.36 and B square is 57.12. If you take the difference, it becomes how much? 4 2.01, 10.24. Now this is the actual value it will be. Now if you know, you must be familiar with some very standard numbers which are perfect squares. That 1024 is a perfect square. It is a square of I guess It is a square root of 38, if I'm not wrong. 38, 38. Let me see. No, 30, 32. Let me see. 64, 24, 30 multiplied by 24. No, 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 no. No, it is exceeding. Maybe 32. Maybe 32. 64 multiplied by 96. Yes, it is 32 square. Now 1024 is 32 square. Okay, so this is we can see that this is 10.24 square root of 10.24. Now if you convert this 10.24 decimal in the fraction form, this is 1024 divided by 100. Why 100? Because it has two decimal places. 10.24 has decimal places of 2. So in fraction it will be 1024 divided by 100. Now this we can rewrite as square root of 1024 divided by square root of 100. Square root of 1024 is 32 and square root of 100 is 10. So this is equal to 3.2. 3.2. So the correct choice is A. Okay, so this brings to an end in solving the sample test paper number 2, and with this I have completed 2 sample test papers 1 and 2 on the chapter of squares and square roots. Next I will start the chapter cubes and cube roots, and also simultaneously I will keep on uploading 10 good problems and solve them on the chapter of squares and square roots in the other playlist, that is CBSE 8 Hot. I have another playlist, CBSE 8 Hot, where I prepare and solve 10 good problems under the category of hot. Hot means HOT means high order thinking problems. 10 good problems every now and then from a particular chapter, as and when they are completed in this playlist, that is CBSE 8 R.S. Aggarwal. So I hope this video was beneficial to you. This will give an exposure to good standard variation of problems and little bit of hard problems, so that you can judge your understanding of your concepts on the chapter of squares and square roots. So if this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So thanks for watching, and until the next video, take care and bye.